Today we're going to look at surface area of prisms. So a prism is a solid with a constant cross section. The cross section is parallel to the two identical ends. Here we've got a diagram of a triangular prisms because we've got a triangle on the end. The two identical ends are the triangles at either end. The cross section is if we were to cut to slice all the way through it, we would get the same triangle shape, the exact same triangle shape. And they are parallel, those ends are parallel to each other. They all, and every cross section is parallel to one another. They all line up to make up the solid. So if we've got an example here of, this is a cylinder, but it is still a prism. It's a circular prism. It's got a circular base. The two ends are circles. We've got two circular ends there, and then there's a rectangle wrapped all the way around to the middle. That's a rectangle shape. You can imagine if I rolled that all the way along, if I covered it in ink and rolled it along a bit of paper, it would make a rectangle shape. So if I were to cut, to slice through this tin, anywhere along that circular cross section, I'd get the same circle shape as either end. And you can see that those two circular ends are parallel to each other. They are parallel, both going in the same direction. So any of those slices that I could take through this cylinder would get that same cross section. If I were to slice it in a different way, if I was to slice it through this way, I would get different shapes. If you look at it end on, you can see if I were to slice it all the way through, I get a rectangle shape, just flat on like that. So if I were to slice it through the first very thin layer, you would only get a very, very thin rectangle. And then if I were to slice it in closer to the middle, I'd get a bigger rectangle. And the rectangles would change all the way through. So that's not the constant cross-section of this shape. The constant cross-section is the circles. And that's why how prisms are named. They're named based on their cross-section. So here we've got a triangular prism, and this special one could be called a circular prism, and it's called a cylinder. So if a net is a two-dimensional representation of a solid. It can be folded to form the solid. So if we were to fold it out, if we were to tip all of the insides, the contents of this container out, and we were to peel back that top circle, peel back that second circle, and fold them out flat, and then roll out the rectangle all the way around the middle, we'd have a flat representation of our cylinder, and we could fold it to make the cylinder again. So we would be left with two circles and a big long rectangle, one big long rectangle that can be folded around to make the container that we have here, the cylinder that we have. So the total surface area of a prism is the sum of the areas of all its faces. So we add up all of the areas of all of the faces, and that's the surface area. That information can be very, very handy when we need things like labels, like on this tin, or we need to paint rooms and things like that. We need to have the amount of area so we know how much we've got to cover. So here I've got a few examples of some nets. Here we've got a cube that we've folded out. Now a cube is a very special prism because it can be cut through many different ways and have the same cross section. So it can be cut front to back, top to bottom, and left to right, and it'll get exactly the same cross section each time. So every side length is the same. So here we can see I've folded it out and we've got 6 faces, like a die. So we've got 1, 2, 3, 4, 5, 6 faces that we've got. And each of the faces is identical. They're all the same area. So the area of one face is going to be length L times L, the side times side, to get just the area of one. We've got 6 times that. So the surface area of our cube is going to be 6 times L squared, so 6 times the area of one of its faces, because they're all the same. So we've got 6 lots of them, 6 times that amount. Here we've got a rectangular prism, and our rectangular prism has length, width and height making up its dimensions. If I were to fold that out, I would get 6 faces once again, but they wouldn't all be the same. We're going to have 2 faces the same, front and back. They're going to be identical. Top and bottom are going to be the same, and both of the sides of the rectangle are going to be the same. And here I've folded it out, so this area 1 here is going to be the same. They're both going to be the same. So we've got, height and length. So height and length, that's going to be the front here, A1, okay, and it's going to be front and back. Here we've got width and length, so that's going to be top and bottom. So these two are going to be the same. And we've got width and height here, A3, the third area, okay, and they're going to be the same. So this is A3 here, the sides. A3, the left and right hand side are going to be the same. The top and the bottom, A2, are going to be the same as well. So we've got 2 times length times width. So 2 times length times width. So that's A2 here, 2 lots of A2, 2 times A2. Here we've got 2 lots of width times height. So that's 2 lots of A3 here, 2 lots of the third area. And here so that's the left and right hand sides, plus 2 lots of A1. So length times height, the length times height here, A1, the front and back. So that is the total surface area of this rectangular prism. We've got 2 times the top, 2 times the top, so that's the top and bottom here, that's the top and bottom, and we add the 2 sides, and we add the front and back. So here we've got an example. Find the surface area of this prism. Firstly, it's a triangular prism because we've got a triangular cross section. If I was to cut anywhere in through here, I would get the same triangular shape. My drawing's terrible, but you get the idea. If I was to cut all the way through there, I would get the same triangular shape. 8 centimetres on this side, 6 centimetres on this side, and 10 centimetres on the hypotenuse. So here I've created the net to try and find the total surface area of this prism. I've folded it out. You can see we've got 3 rectangles making up these faces. We've got 1 rectangle here, another rectangle here, and another rectangle on the bottom. So 1 rectangle is that slope, the back slope, and the base of our triangular prism. So we've got those 3 sides, and we've got the front and back, which are both triangles. So here, the front and back, as we know, are going to be the same area, so I've marked them as A1, and we know that that's going to be a right angle, and that's going to be with a base of 6 centimetres and a height of 8 centimetres there. So that's a height of 8 centimetres. Each of our rectangles is going to have a length of 15 centimetres because that's going to be the same length, 15 centimetres for each of those sides. So one of those rectangles here is going to be 15 centimetres by 10 centimetres. That's our first area up here, A2. We've got A3 here, which is going to be the back of our rectangular prism. That's going to be 8 centimetres by 15 centimetres, A3. And our last face is going to be this rectangle on the bottom, which is A4, and it's going to be 6 centimetres by 15 centimetres. So, in order to find the total surface area, we've got 2 shapes the same here. So we're going to have 2 times A1 plus A2 plus A3 plus A4. So I'm just going to add them together. So we've got 2 times A1 plus A2 plus A3 plus A4. So these are the different areas that we're adding up. Here, 2 times the area of a triangle is a half base times height, plus the length and width of A2, plus the length and width of A3, plus the length and width of A4. So if we have a look at our triangles, our base of our triangle is 6 centimetres, multiplied by the height of our triangle, which is 8 centimetres. So we've got 2 lots of them, 2 times a half base times height. So that's going to be our triangles, our 2 triangles. Here is our first rectangle, area 2, A2, which is going to be length times width, 10 times 15, plus 8 times 15 for our second rectangle here, A3, 8 times 15, plus 6 times 15 for our last area, A4, 6 times 15 there. So just working all these out, that's our triangles both together equal 48 square centimetres. Our first rectangle is 150 square centimetres. Our second rectangle is 120 square centimetres, and the last rectangle is 90 square centimetres. Adding all those up, we reach 408 square centimetres. So, just as the basic steps for doing a problem like this, for working out the surface area of a prism, firstly, I turned it into a net. We folded it out into a net, and then I tried to find which shapes were the same. And those ones here, we found the triangles were the same. Then all I need to do is add up all of the areas of all of the shapes, making sure that I've taken the measurements here and put them on my diagram to help me out. So I know that area 2 here was 15 times 10 centimetres. Here this is going to be 8 times 15, and this one is going to be 6 times 15. These ones here are half base times height, so they're going to be, the area is going to be 1/2 times 6 times 8 centimetres. Okay, so we've reached our answer there. The surface area of our whole prism is 408 square centimetres.